Okay, so my talk is called like Tiny Little Birds, and I'm going to talk about Canary tokens. Which of you have worked with security or are interested in security in this room? Yes, good question. Yes. Okay, so who am I? If you want, please scan, connect on LinkedIn, all that. I'm Mostafa. I'm a lead security engineer at TigerData. That used to be called Timescale DB. And I'm basically all over the place. So if you search my name, you will find it definitely. Interesting. Grafana got hacked. Okay, fair enough. It's all basically what I'm saying here is just public knowledge with a few pinches of more information. But yeah, so if you check the Grafana blog, I've sent the short links here. This is the incident that happened. And I'm going to talk about how it happened, the attack pattern, how we prevented it, and so on and so forth. And this is the next one is the postmortem. So basically written by our CISO back then when I worked at Grafana. And we detected that attack and prevented it. And we've written in length or at length about how we detected it and how we prevented and continuously prevented it, basically. And you can find the links here. I will share the slides with the organizers so that they can share it with you if you want. So, but how did we do it? I'm going to talk about how it happened, the detection mechanism and all the details, a short demo of GCP Canary tokens that I prepared real quick like 2 days ago. So, and then the incident response strategy. So basically when you detect something, you should do kind of raise an incident and then do things to prevent this from happening again. And then QA. Feel free to interrupt me. I'm okay to be interrupted. But if it's a very long question, long answer, please keep it for the end slide. So, how did it happen? One of our nicest colleagues decided that it's a good idea to merge a pull request on GitHub that included a trigger called pull request target that basically allow forks to submit PRs and those PRs to trigger GitHub action runner and make full use of it. Basically, no restrictions on what it can execute. And imagine all those runners are on our infrastructure, basically called self-hosted runners. And then after merging of that PR on a Friday evening, don't do this, please. Not if you want to make security kind of suffer the next day. So they merged it, and then there is this tool a great security person wrote called Adnan Khan, called Gato-X, which I'm gonna show you in a few slides. So someone ran this tool, found this repo with this vulnerability. It's not a vulnerability, but technically it was because that workflow included two steps that allowed the attacker to make use of our runners and dump the environment variables. And that too was the issue comments. So we were processing issue comments and issue title or PR title as a command or as a text without sanitizing it. And also we were generating an ID token for basically anyone. And imagine the pull request target plus ID token means you have unlimited access to GitHub API to even look at private repos in the same company, means Grafana, and so on and so forth. Okay. Unfortunate turn of events. The attacker used a JavaScript kind of one-liner and use curl in that one-liner to run curl inside the runner, self-hosted runner, and basically extract environment variables and send them to its own CNC server. So that's how they exploited it. How did we detect it? So a while back, like 6 months to a year before that, I was tasked with like investigating what Canary tokens are, how we can like leverage them and all that. And then I generated Canary tokens, which I will explain what they are in the next slides, at org and repo level GitHub secrets. Okay, I generated an API key. Imagine an API key is a Canary token. I generated it, put it in GitHub secrets. That was it. It shouldn't have been touched. But the attacker, while dumping the environment variables, thought they are smart, and they used TruffleHog, which is a secret scanner, an open source secret scanner, and passed all these environment variables to TruffleHog. TruffleHog validated the secret, means it made a call to AWS API, which was the Canary type, and we immediately got an alert, and almost immediately raised an incident. I was like, nobody should touch this, like ever. This means that we are toast. So we quickly contained it. We removed the workflow, removed the PR, kind of disabled the GitHub Action workflows on all repos, tried to rotate the secrets. It's just 3 words, rotated all secrets, but it took 300 engineers over 2 weeks of work to rotate all the secrets. Imagine more than 3,000 repos on GitHub on our org, and each of them containing 50 to 100 secrets. And those secrets are like API keys, certificates, all the basically can of worms. We have to fix that. And then we did a lot of things to harden so that it doesn't happen again. So we kind of we do blocking on PRs with a workflow with Zizmor. I'm going to explain it. We also scan secrets on each PR workflow. We use Gato-X for verification. And then we migrated from GitHub Action secrets to isolated vaults. So basically, each repo has an isolated vault on HashiCorp Vault, and it's audited, fully audited, and basically this issue, the pull request target, which allows GitHub Action secrets to be available to the forks so that they can run the workflow, is no longer the case. We can control it with Vault on who can access the secrets, basically. So even if someone accidentally changes this, a workflow, instead of triggering on pull request to trigger on pull request target on the forks, we can just control it. Like, don't let them access the secrets, basically. Or basically define trust boundaries. That's it. I'll explain later. So I told you about Canary tokens, but I never explained what it is. So what is a Canary token? A Canary token, in its like simplest explanation, is an API key, a file, a set of credentials, a certificate, anything, basically anything that is created but should not be used or touched. So it's like an alarm system. You turn it on, and after that, nobody should like enter the house or the company or whatever. And if one does without the correct credentials, it will trigger the alarm. So it's basically a digital tripwire for protecting company assets. The good thing about Canary tokens is that so there's this notion where like some security or defense mechanisms in security are pre-compromised. So you put things in place to detect things before you get compromised. Unlike a Canary token, which has a very high signal to noise ratio, but it's used post-compromise, which means that you create a Canary token, you put it in secrets, and then you wait for the attacker to use it. So it means that they already are in your system, and you're defenseless. So you use the Canary token to finally capture that hacker. Anyway, so this is a good one. There are two ways to basically build your Canary token infrastructure, as I call it, or as it's called. One is the DIY, which I'm going to show you right away, and also one that is the automated platform. So basically, the DIY means that you have to like mix and match. It's a Tetris. You have to mix and match all the blocks for it to work. It might not be as robust as the second method. Second method, like platforms like Things, which has an open source tool as well, and also Tracebit. These are two companies who basically have automated platforms where you just create the token, place it somewhere, they monitor that token, and when things happen, they just alert you. So this is straightforward, basically. And that's how we did it with Grafana. So we used the Things platform instead of doing it DIY, because DIY has a lot of maintenance overhead. But with that said, let me just show you how you can create a Canary token. Let me just show you the things. So this is like canarytokens.org. If you go here, you will see different types of Canary tokens. I'm going to generate one and show you something the first. Okay? This is the reminder where you can create as many tokens, basically. This is a reminder for you that when it's triggered, it will show. It can be JSON, it can be basically anything. It's a reminder for you. And then that's my email. So I'm going to generate this. I don't have internet. There you go. Oh, God.
Try to record guest. It shouldn't.
Oh, I have the key to the kingdom. Yes. It worked, actually. Let's call it the fest for this to be. So I want to show you. Okay, can you please scan this? Someone. Just want it to be triggered. I can scan it myself if.
Mine's recording, sorry.
Okay, fair enough. Done? It worked? Or?
I just scanned it if the page is loading.
Okay.
We have it now. I have the white.
Okay, it's triggered. Thank you. Okay, so this is it. Basically, this is my email. You see that the token is triggered, means somebody scanned the QR code. This is the simplest form of a Canary token. So it shows the source IP, date, time, the user agent, and then you can go to alert history and see, okay, basically where it's from. So it's probably from, Berlin and so on. And you see all the different IPs and where they try to access it, okay? So we created something, we placed it on display, somebody scanned it, I received the notification, now I raise an incident, okay? Very simple, or at least I think so. There are other forms as well. Let me show you another one. AWS keys. It just generates something. Yay. Okay, so you see AWS secret key ID. These are valid secret key IDs. If you put it in a file and give it to AWS CLI, it will work, but it has access to nothing. The whole point of this is to capture the attacker. Okay? And you can copy this and put it in your secrets or a file on your disk, anywhere you think is important for the attacker to look into. So, shameless plug, I'm through the GD Academy and I have to explain the GCP. and it's also it's step fast. So I created a simple Canary token. This is the other one was the automated version. This is the DIY version. It has many steps. So I created a service account, okay, with no permissions. So if I go here, you will see. Also, I named it Juicy Lady. You know, admin dash full access. It's the best token you can use on in your life. You know, and then if you look, there are no permissions, like literally none. It has access to nothing. But unlike AWS API keys, AWS API keys, you have to explicitly say this has access to STS get caller identity. Otherwise, it won't work. It's just say access denied. But this one is different. With this, which I can just show you, I just downloaded the key. I generated a key for it, and it's active. And I downloaded it and put it to kind of gcloud, put it somewhere, imported it into gcloud. Let me see if I can find the command. Gcloud, there you go, this is it. This is how I activated the service account. This is how an attacker would check it, or use TruffleHog, either way. So I kind of get the access token, and then if I'm lucky, I will be able to check the projects from the Cloud Resource Manager, check the list of projects. It will return nothing, basically because it doesn't have permission. But I'm going to trigger it a few times because I want to show you eventually. This is a DIY thing, so it might not work during our talk. What I did was I also, for this token and also for other things, I enabled, for the Cloud Resource Manager API, I enabled audit trails for any accesses. For IAM API, I enable for security token service and service metadata API. So basically, anywhere the attacker kind of tries to see if this token works, I will get an audit trail, basically, an audit log in IAM admin audit logs. Okay. Let's see if it works. Or it worked. It takes time for the logs to just be ingested, for especially audit logs. There is a delay between the time you trigger something, and it's not as fast as the automated one. But yeah, I mean, there's so much you can do. Then also, you can also check this one should be okay. Come on. Yeah, it also takes time. Let me just refresh the page. No, it picked up. So basically, we have a metric over service name, API request count, with the monitored resource being the consumed API, basically any API that is called by the attacker. And then the fun part is that we can create an alert policy from this metric. We can also do it with logs as well. And that policy looks like this. So basically, it's something. It says get a sum over this rate, over 1 minute. And then if it's more than 0, basically send an alert. And then you configure it to do evaluation every minute. So in a minute, I will receive an email. And then the retest window is also 1 minute. And the notification, I set my own email here as a channel, and then Canary trigger act fast. So if we are lucky, we should be able to. If not, I have one. So it looks like this. You receive this. You see, it's much less information than the automated version, but still, you can just go view the incident and then from there go to the logs and see which IP address try to access that API. And just make sure not to use a project that you use for your work. Just create a separate project, create separate stuff in it and use that. So that's basically it for this part. What is the life cycle of a Canary token, as I explained? So you just saw how how it looks. You just create it. You put it somewhere. It's in secrets, anywhere, on disk, on Google Workspace account, anywhere you think, on Slack, on a public channel on Slack. People will look at them like, if they get access to your systems. Then you monitor those resources, basically. If it's automated, it's already being monitored, so that's okay. You get an email, you get a webhook being called, whatever. Basically, you will be notified through a channel that this is triggered. And then you get to respond to it. I mean, hopefully, if you see the notification and don't just skip it. So next part is TruffleHog. So TruffleHog is a very interesting, mature security project for detecting secrets or scanning and detecting secrets in GitHub repos, in commit logs, in files, whatever, in file system. And it has the ability to validate them as well. So basically, it finds them and says they're like invalid or valid. But the good thing is that attacker didn't know, unknowingly passed all the environment variables to TruffleHog. TruffleHog was like, wow, nice. Yeah, we have a lot of secrets. And then it bumped into the Canary token. So there's one thing you should know is that the free version I just shown you from Things, the green page and the QR code, for the AWS API tokens on the free version, TruffleHog just says this is a Canary. And it detects it based on the account name. But if you pay the company, they won't, yeah. So that's how we detected it, basically. So this is a gotcha, you should.
Will it still trigger though, so it's still too late, right?
No, so it won't trigger because it knows it has the list of accounts. There's actually, funny, there is a blog post on TruffleHog blog, and it says it won't trigger free tokens, but we won't enumerate the paid ones. So good for us, good for us. So with all that said, so I explained what Canary tokens are, what to do, and so on and so forth. We should also think about the placement strategies. Basically, there are different types of tokens, as you've seen. There are Canary tokens and so on and so forth, but there are also file type tokens. There are commands, there are PDF file tokens. Like you can create a PDF file, and if you have MDM, like mobile device management in your IT that you install on your machine, they can push these Canary token PDF into like juicy directory names on your machine, so that if someone gets access to your physical machine and clicks that PDF, which is randomly called my passwords, okay, it will trigger the token, okay? And also there are like Google Workspace docs and sheets, if I'm not mistaken. So it's a normal doc. It could be empty, it could contain something. But the moment someone clicks on it, it just generates an alert. But the problem is these are in Google Docs are in a sandbox, so the IP is not the attacker's IP. But at least you know the email that was compromised that took access. And also about the strategic locations and asset mapping. So what we did manually was to put them in Vault, 1Password, GitHub Secrets, Slack, Google Workspace Docs. But it was okay, you know, a few tens of tokens. You can do it manually. It takes 20 minutes to one afternoon. But then Grafana has something. Grafana has 10 million Kubernetes nodes. 10,000 Kubernetes nodes. Wow. And 260,000 pods and such in its infrastructure. So how do you secure that? Do you just create one token and put it all over the place? Then how do you know where the attacker came from? How do you pinpoint? So this is the strategic location I was talking about, and the pinpointing strategy, which I explained. Oh, by the way, all of this is in the blog post I wrote on the Grafana blog, which was in the slides. So with that said, I created a mutating admission webhook to generate the tokens and inject them to pods and containers on the fly. So anyway, so you can automate this process. That was the gist. Okay, I gave you the demo. So we are reaching the end, if I'm not mistaken. Yes, right on time. Okay, so what is it? What could be the best incident response strategy? Is that you do two sorts of actions. So basically, there's an incident, an active incident, something happened, things are on fire. You have to take immediate action. I mean, you have to stop the bleeding. If you've been to an ER, emergency room, hopefully not, you will see that there is the triage room where they try to stop the bleeding, like literally stop the bleeding. And then when things are in a normal state or somewhat normal state, they will pass it on to the doctors and other people. This is the same exact thing we should do. When a security incident or any type of incident happens, we should take some action to stop the bleeding. Should stop the actions from triggering again, so that the attacker finds a new foot door to kind of enter our realm, basically. And this for us was stopping GitHub actions altogether for the entire org. There's a checkbox, you can disable GitHub actions. And from then on, none of the PRs, nothing would trigger any actions, which is a good thing for us, at least, on a self-hosted infrastructure with exposed, exfiltrated credentials. And also, we rotated the secrets, as I said, 2 weeks of time and so on and so forth. And we used TruffleHog. We actually used TruffleHog ourselves. So we were rotating the secrets, and we were actively using TruffleHog on existing secrets to see if they are actually rotated and they're not valid anymore. This is very important. I mean, rotating the secret is one thing, invalidating the previous one is yet another thing. So the attacker has the previous secret, like the previous secret, and they can still trigger it, and they can still access your platform, code, whatever you have. And also we use Gato-X again on our own infrastructure to see if there are other vulnerable workflows on our GitHub repos, having pull request target and all that. With that said, we also took some preventive action. So basically, things we did to prevent this from happening ever again or again. One is using Zizmor and many other linters. Zizmor is a static. Let me show you. So this is TruffleHog, by the way. And this is Gato-X, and this is Zizmor. Zizmor is a static analysis tool for GitHub Actions. Zizmor. And then you can basically use it to, and you can run it against your GitHub Actions, your repo, whatever, locally, remotely, however. And then it finds like template injection vulnerabilities, accidental credential persistence, excessive permissions, imposter commits. There's a huge list, like a huge list of audit rules. It runs over your basically workflows, and then it gives you ways to fix it. And since I'm a contributor, shameless plug, I also added the auto fix feature. So before I added this feature, it was just detecting things with some basic suggestions. Now it can automatically fix it. Like as in, like you can just say --fix equals all and fix it right in place in your YAML, and then you can submit a PR to your repo. That's that. The next one is Gato-X. So Gato-X is also another static analysis tool and exploit toolkit. So I believe you're all professionals. Don't try this at home, or or suffer the so that you suffer the consequences. But anyway, so this can find vulnerable GitHub actions that you can use to take over a company, a repository, a company account, or don't do it. Don't do it, please. Come on. And then the last piece of the puzzle is that from then on, we were like, okay, we don't have fine-grained access control over our secrets on GitHub Secrets. This is not good. This is not good at all. And as I mentioned, somebody enabled the gates of hell, and somebody found the issue, kind of leveraged it. What we did is that we moved all of our secrets after rotation to a separate vault and created a shared action to inject secrets into trusted repositories. And this is important because even if you now on GitHub account, someone accidentally merges a pull request target, they won't be able to extract the secrets. Secrets won't be injected into that workflow unless we say so. This is good. This is a preventive action, so it won't happen again. And also we fixed a lot of other things. We hardened our self-hosted runners. We did all sorts of like research to prevent this from happening again. And then after that, there was this blameless postmortem. This is very important because there are a lot of lessons to be learned, especially if you're hit hard by a security incident and spend like, I don't know, 2 weeks of 300 engineers to fix it. So it's a great learning experience in my opinion. And you shouldn't blame the engineer who, thought it's good enough to just merge something on a Friday evening. That's the whole blameless thing. And yeah, postmortems are very important because then you know what happened and how to prevent it and who not to blame, basically.